Hi everyone, I am Dr. Suriya, Assistant Professor, Department of Civil Engineering, JJ College of Engineering and Technology, Trichy. Today I am going to present some important topics in prefabricated structures in civil engineering. So let's start with the course objectives. So the course objectives mainly focuses basic concepts of prefabrication, types of joints and connections in structural members and structural stability, design principles in prefabrication as well as prefabrication components and systems. And course outcomes. After completion of this course, the students will be able to understand the principles of prefabrication, production and transportation process involved in prefabrication method, followed by panel systems and characteristics of slabs, beams, shear walls and columns, design of cross section, joint flexibility, joints and connections and structural stability. Next, units. This course consists of 5 different units. Unit 1 consists of introduction part of prefabrication method, which includes advantages of prefabrication, basic concepts and fundamentals of prefabrication, and also limitations in prefabrication and principles of prefabrications. Unit 2 consists of various prefabricated components and different systems used in prefabrication method. And Unit 3 consists of design principles and design aspects used in prefabrication method. Unit 4 consists of different types of joints and connections involved in prefabrication method. And finally, Unit 5 consists of design for abnormal loads such as earthquake and seismic loads. We are going to discuss about Unit 1 introduction part, particularly introduction to prefabrication, need for prefabrication, followed by concepts of prefabrication and history and evolution. Next, what is prefabrication? Prefabrication is generally a modern construction technique in which different structural components and structural members are manufactured in a factory setup before being transported to the construction site. These components are then assembled quickly to form the complete structure. Challenging phases in prefabrication. By compared with the normal conventional construction process, manufacturing phase, transportation phase and assembling phases are considered as most challenging and risky phases in prefabrication method. Next, how does prefabrication work? So it generally begins with the preparation of structural design and detailed drawing. After that, based on the structural design and drawing, structural components are manufactured in a factory setup. After that, the components checked under quality auditing. After that, components transported to the construction site. After that, assembling process takes place, and finally joints, connections and finishings works carried out to get the complete structure. Next, major components of prefabricated structures. So prefabricated columns, precast beams, precast slabs, wall panels, staircases, roofs, of course, doors, windows and service modules are the major components. So each component is manufactured according to standard dimensions to ensure proper fit during the assembly process. So next, step-by-step activity in prefabrication method. By compared with the traditional method, the step-by-step process is unique. In this method, the step 1 consists of design approval, design aspects considerations. Step 2 consists of mold preparation, and step 3 consists of reinforcement fixing, and step 4 focuses on concrete casting work. Step 5 focuses on curing, and step 6 deals with the quality inspection, quality auditing, and step 7 deals with the transportation process, and finally step 8 is site assembly and erection process. Next, quality control. Every component is inspected before leaving the factory. So after manufacturing process completed, so quality is a major concern in prefabrication process. So by using engineers can check dimensions, strength, surface finishing work and reinforcement positions. The interesting fact in this process is factories use laser measuring device to detect micro errors smaller than 1 mm. Next, Quality checklist. We use dimensions checking to ensure correct sizes before transportation process. And the engineers use concrete strength checklist and reinforcement position checking process for ensuring proper load transfer, and embedded parts checking carried out to ensure easy installation process, and finally crack checking process involved to avoid failures, structural failures. Then next, why do we use prefabricated structures by compared with the normal traditional building construction process? The justified answers are, so it ensures factory controlled quality and supports environmentally friendly construction and optimizes material usage with minimal waste and improves planning and logistic management, so less affected by weather particularly. Next, disadvantages of prefabrications. So disadvantages are the negatives. Careless handling leads to surface damage, and attention to be paid to the joints and the connections. Of course, leakages can be possible at joints, sometimes requires higher transportation cost. In some cases, it requires heavy duty cranes, which highly influence the project cost. Finally, local jobs may be lost because it doesn't need any unskilled laborers. Next, prefabrication classification. Prefabrication classified into different types based on different sizes and methods involved. So the types are off-site prefabrication, cast-in-site prefabrication, total prefabrication, partial prefabrication, medium prefabrication, small prefabrication, and large prefabrication. Next, applications of prefabrication. So nowadays we can use it for residential apartments and the construction of educational buildings and hospital buildings, industrial buildings, warehouses, bridges, metro stations, airports, disaster relief shelters, smart city developments, and sustainable infrastructure projects. Next, the demand for prefabricated structures. So we have three major reasons we compared with the traditional methods for the justification of why we have to use prefabrication instead of using traditional method. The three major reasons are faster construction process, economically feasible and sustainable, as well as there are three major factors influencing the shift from conventional to prefabrication method. So the factors are rapid urbanization, labor shortage issues, and the need for faster project completion. Next, need for prefabrication. So increasing demand for rapid infrastructure development, increasing labor cost, requirement for better quality and standardized construction. So need to reduce construction time and project delays are the major needs for prefabrication. So next, model development of prefabrications. So nowadays we can use BIM, automation and robotics in prefabrication method, and the countries such as Japan, Sweden, Singapore and China and the UK have widely adopted the prefabrication method for their infrastructural developments. So in India, the government initiatives promoting affordable housing, smart cities and sustainable infrastructure have accelerated the adoption of this method. Next, history and evaluation of prefabrication method. So in ancient Egypt, the people used large stone blocks to build the pyramids. So after that, ancient Rome, the people used a standard size of bricks for building the aqueducts. So in the year 1624, a prefabricated wooden house, timber house, was shipped from England and assembled in North America, USA. In the year 1851, London, England, the famous Crystal Palace was constructed using prefabricated iron and glass materials. So 1914 to 1918, the time period, in the Europe during World War I, military camps, hospitals and storage facilities are provided by the government by adopting prefabrication method. So between 1939 and 1945, in Europe and Asia during World War II, prefabricated houses projects are implemented by using prefabricated houses and shelters. So 1945 to 1970, in Europe and North America, large-scale prefabrication housing projects were developed after World War II. And finally, 1990s to present, in worldwide, advanced precast concrete, modular construction, and BIM, robotics, and automation become common. Next, in the year 2008, China 15-story hotel was assembled in just 6 days. After that, 2015, again in China, built 57-story skyscrapers in just 19 working days using steel modules. So 2016 to present in Singapore, mandatory adaptation of prefabricated, pre-finished volumetric construction. And in the year between 2020 to 2021, worldwide, rapid construction of COVID-19 hospitals using prefabrication method. So from 2022 to present in India, we use modular system in metro rail stations, airports, affordable housing and smart city projects. Next, hospitals built during emergencies. So during disaster and pandemics like COVID-19, prefabrication helps construct hospitals within a day instead of months. This technology saves many lives. Next, prefabrication reduces construction waste. So traditional construction creates large amount of waste like debris. Factories reduce waste by cutting materials accurately, so the waste reduction can exceed 50%. So next, usage of cranes in prefabrication. So generally, mobile cranes used for small prefabrication houses, and crawler crane used to heavy lifting process, and tower crane used for high-rise building, apartment buildings, and overhead cranes used for manufacturing plants, and gantry crane used for factory yards, and truck-mounted cranes used for transportation process and lifting process, and rough terrain crane used to manage uneven sites. A telescopic crane used for a flexible lifting process. Next, houses can be relocated. Is only possible in prefabrication method. So some prefabricated houses can be dismantled, transported and rebuilt somewhere else. So like moving like a giant puzzle. Similarly, so hotels can be expanded. So less traffic around construction sites and less water consumption. So only possible in prefabrication method. Next, prefabrication, the amazing engineering. So just imagine bridges can be installed overnight. Prefabricated bridge sections are transported at night. Roads reopened by morning, only possible in prefabrication method. So likewise, schools built during holidays. The entire classrooms can be assembled during vacations. The students return to brand new buildings is possible nowadays. And disaster relief homes. So after flood, earthquakes and cyclones, so temporary prefabricated homes are built quickly. The families get shelters much faster. So next, some environmental benefits in prefabrication method. When compared with the normal traditional method, so prefabrication has a low material waste and low dust pollution, moderate in noise and lower water consumption and easier recycling process and lower carbon emission. And next, future cities will be modular. Construction will become much faster. So most experts predict future cities will use modular hospitals, modular schools, modular apartment and modular offices. Next, summary. Today we discussed topics related to introduction part of prefabrication, need for prefabrication, concept of prefabrication and history and evaluation. Thank you. So if you have any queries, contact me at Suriya at jjct.ac.in. Thank you.